All right. So today, as many of you are aware, Facebook has gone down for a lot of people. And by a lot of people, I'm talking the entire globe. The entire internet has lost access to Facebook. And we're getting a lot of questions in of why that had happened. So I figured I'd make a quick little video to explain exactly what we're seeing. So to start off, you first need to kind of understand how DNS works. DNS stands for Domain Name Service, and it is basically the global catalog, if you will, of mapping a name like Facebook.com to an IP address. And an IP address is a unique identifier. It's a number that computers need to be able to communicate and talk to each other. So, what this all basically means is we're going to go ahead and show you a couple troubleshooting things to help us kind of isolate where this problem actually lives at. So we're going to go into PowerShell window here. We're just going to do a basic ping. Ping is we're just trying to send uh, a couple requests to see is it up or not. As you can see right away, it doesn't even try to send a message to Facebook because it can't find it at all. This is what it should look like. Let's do like google.com. So you can see how we get responses back. That's a good indicator if to test from a networking perspective if the network's up and running or if there's an issue on the server side or if there's a DNS problem. And what we're seeing here is clearly a DNS problem. So now to try to figure out exactly at what layers is failing at DNS, because DNS is a very complicated and hierarchy based system. And so you can change your DNS server, which could possibly solve this problem if the DNS is local, if the problem is local to the DNS server that you're using. For example, your internet provider. If you've got like Comcast, for example, if their DNS problems haven't, or if their DNS servers are having the problem, and you change them, then there's a potential that it would start working for you. So let's start running some tests to see exactly how far this DNS problem is actually happening for Facebook. So let's clear this window. And the way we are going to do this is by running a command. It's called nslookup. And this is basically us telling our DNS server, tell us what you know about Facebook. And in this case, we're just using my default uh, uh, here DNS server, which is pfSent firewall. In this case, it can't find it. So then the next one up would be let's check an ISP one. And so let's take a look at Comcast. Comcast is not my ISP, but I'm going to go ahead and just pick them because I've got their DNS server memorized. And you can see they also don't know where it's at. So let's ask Google. Google has their public DNS servers. Let's see if Google can tell us where it's at. Not a good sign if Google can't identify you. Let's just check one more Google DNS server. All right, so as you can see, three big public DNS servers are not seeing this. So the next step that you can do is look for that very top level DNS servers, and that's published here. So as you can see, I'm going to pick on Cogent, and if you go through, you can pick whichever ones you want. I've already gone through all of them. They're all the exact same. That's how I know this is a global issue. So over here in my text file, I've got the DNS server for Cogent. And so the way this works is, so what we initially did was going from the bottom up. Now we're going to go from the top down. So all we have to do is plug in that IP address. And now all of a sudden we're going to start seeing some information. Now what we're looking at here is basically that top level domain server saying, hey, facebook.com DNS server should live uh, in one of these servers, that record specifically. So this doesn't exactly say this is the exact IP address to Facebook. This is just pointing it down to say, hey, last I've seen, this server should be able to help you with that. So let's just go ahead and grab this very first server. So then we just repeat the process. And now we're going to the second layer. So now at this point, we do get back some IP information, which is good. Now we do see, the actual name of these servers we're talking about is these are the actual DNS servers that Facebook uses. So if we were to query one of these IPs, this should tell us exactly what IP address Facebook lives on. And look at that, it times out. That's not a good sign. and eventually it will time out, and then we can go ahead and try a different one. Let's try the IPv6 address. So the first address that we used was IPv4 DNS server. Here's their IPv6 one. That one fails immediately. Let's go down the list. Let's just pick on the next one. So this is why companies have multiple DNS servers in case there's issues like this. And you can see it fails again. I'm going to just force timeout here, so we're not going to watch it time itself out. We'll just go down to the next list. And like I said, I've already ran through all of these tests here. So basically, what this tells us is the entire Facebook DNS has been deleted. And the only way that would have happened would be from an insider access. Now, there could be a couple ways that could have happened. One would be if a administrator, an internal administrator, network administrator, basically had their credentials compromised. Then an attacker would have been able to authenticate on behalf of that compromised account and then make this change. One of the biggest problems here is the way DNS works is it replicates throughout the entire world, and that propagation can take up to 48 hours or longer in some cases. And so chances are what we are seeing happen was, it's been down for most folks all day, but chances are that deletion happened earlier this morning or even late last night, and it took it a while for it to propagate those changes. So then what that means is once Facebook rebuilds those changes and puts it back out there, from the time they hit save and submit on their DNS servers, it can take another 24 to 48 hours for those records to be repopulated. So what we're looking at here could be a 48-hour or longer time of downtime. And where it gets really tricky is when you're in really big companies like Facebook, they have a ton of DNS records. And if those records were never backed up or saved, or if they were backed up and saved, but whoever attacked and deleted those also got access to the backups and deleted those as well, or had encrypted them, then they are in a potential situation where they'd have to create brand new records manually, which could take a very long time. So very big issue that we're seeing here. But just wanted to come on here to show everyone how quickly you can go about trying to troubleshoot internet problems like this. And how you can go about and figuring out where the problem actually lies. So in this case, it's not your internet provider. It's not Google shutting down. This is directly related to Facebook settings on their DNS servers. So hopefully they'll get back up and going, and we'll have a post-mortem to figure out exactly what happened. Because as of right now, it definitely does not look good. And they should have had some type of detection capabilities in place. Where if a administrator goes to make a change, they should have got alerted on it, and or had some type of way to have like an approval system in place, so not one person can go in there and just blow everything up. So it's possible that there were multiple accounts that were compromised. The other side of this is this could be a straight up insider threat. This could have been malicious intent by an employee. We just seen the 60-minute whistleblower from yesterday. Whether it's tied to that or not, who knows? But as these Facebook security team starts their investigation, I'm sure they'll be able to figure it out. Hopefully they've got the appropriate logs and access that they need. So thank you all for watching. My name is Nick Lockard, and I'm with Lockard.it. We provide cybersecurity services. So check us out at Lockard.it to learn more. Thank you for watching.